Hello, YouTubers. This is a new session where I get to explore to you and explain to you a little theory that makes it a lot easier to understand how to architect, develop, and solution and engineer AI-driven systems. This is not a particular framework or a particular coding session. This is more about holistically understanding how to put together the components that you need to develop an AI system and basically architect a solution that can be developed in any technology or any framework you like. So for starters, what is, an AI system, right? A system that you can develop, that you can send it some prompts, some questions, and it intelligently, can understand, that prompt or that ask or that requirement. It makes a decision on its own and it takes an action on its own. It's very commonly known as agentic AI systems. And, this is what you interact with on the daily basis. Like if you go to any AI-based chat, it doesn't just talk directly to the large language model. It actually grows through multiple layers of like security, filtering, and then it starts going out there and looking for some answers because LLMs on their own, they don't necessarily have up-to-date information, right? Like if you just pull an offline LLM and ask it some question, it'll tell you like my data, my cutoff date on knowledge was like 2023, 2024. So if you ask it what the weather is today, it'll be like, I don't know. It might guess some answers, but it's most likely it's not going to be accurate because it's not connected to the internet. It's not connected to live data and it's unable to take action on its own. So it's a good brain, but it's a brain that's locked in a room that can't actually hear anything or see anything or take any action. It can voice some thoughts, but it can't actually tell you exactly, an accurate answer or take an action on your behalf and so on and so forth. What I'm about to talk to you about is a theory. A long time ago, I talked about, the tri nature of things, how every system in the world is dependencies and, decisions and exposure layer. And this falls right into that. It's a universal theory. It's going to help you understand any system out there. And I'm here to talk to you about the tri-nature theory when it comes to developing AI systems. So, what is this about? Assume, well, first let's talk about the tri-nature theory. So, the theory basically says everything in the world, any system, no matter what it is nothing but a dependency and a purpose, like intelligence and exposure, right? What's an example of that? It's very simple. If you take this and say, this computer that you're using right now, or the phone that you're using right now, it depends on electricity, right? So it needs electricity, and then it kind of has a CPU, right? Central processing unit, or compute processing unit, right? That's the one that takes the electricity and turns it into, something that you can look at. And then at the end here, you have like a monitor or a phone screen or whatever. And this monitor basically is your exposure layer. So this is exposure, this is purpose, some intelligence, and then this is the dependency. Everything in the world, you yourself, is a dependency and a purpose and an exposure. You eat food, you need food to survive. You have a purpose. Let's say you're a programmer, so your purpose is to make decisions about writing code and whatnot. And then the exposure is you actually taking the actions or talking to people or creating systems and whatever the case may be. This is what I call the tri nature of everything, the tri nature of everything. Okay, it makes sense to develop a standard that helps us understand how to develop AI-based systems, right? Like intelligent systems that can work around this theory. So let's take a new page here. Let's just think about this. In that same example, I can simply say that every system in the world will have some form of uh, data or prompt coming through it, some trigger. It doesn't matter what this trigger is. And then there's a decision that has to be made. Think about it as interpretation. And then lastly, there's the dependency. Dependency. And the dependency here is basically the action that you're taking. Like you're sending a request over the wire. The request, comes in and, like an API request. and the request goes into a service, and the service validates it, makes a decision. Is it an upsert? Is it a delete? Is it, just in that simple form? And then it basically calls a database. So it takes an action, right? In an AI system, it's the exact same idea. The exact same idea. When you send a prompt, it goes to some sort of an LLM. The LLM, will make some decisions, and then eventually it'll take some actions, right? So let's kind of make it nicer. So you get data, and then there's a decision, and then there's a direction, just like that, right? Data is the exposure layer where you're getting the input. A decision is where you do the intelligence, and then a direction is the dependency. The thing about AI systems, though, is that it can it can continue to work in that fashion, or it can stop, and that's the idea here. So think about it as a some kind of a loop, right? This loop basically, once a direction is taking, new data will come into picture. It's not necessarily a prompt, but it's new data that comes into picture. So you kind of iterate, you continue to iterate on the model until you come to the particular answer. So this is here, iteration, right? And you start over. This is an AI system. This is an agentic system. And I'll give you an example real quick. Let's say, for instance, you have a prompt here that says, what's the weather? So that's data that's coming through. We're gonna go here and say, okay, well, the decision is, right, I need to know location, right? So in order for the system to know what the weather is, it needs to know the location. And then based on that, it will go and talk to the direction, which is the action, go get location. So we want to get the location either through answering the user and saying, hey, where you're at, so I can tell you the weather, or by calling an MCP server. And we're going to talk about that. Talk to an MCP server to go and get the current location for this person. Okay. As soon as the location has been observed, watch this. It's going to go back. I'm going to kind of layer it for you so you kind of understand. It's going to go back to this guy and basically say, here's the location of person, the person that prompted. And then in here, when I need to know the weather of location. So based on this location, I need to know the weather. And then here, we're going to go and say, get weather for location. So you see how the system kind of iteratively, and then once that's done, you're going to go back here and basically say, watch this, another iteration like that. See how the system is kind of working in a particular way. Here you are. And then basically say whether this is the data that you're sending, um, um, format whether in a natural language, and then basically whether formatting or something like that. And you basically produce the answer. So it starts with a prompt and it ends up with an answer. You see how the iterations here, it has gone through. So this is a prompt, and it ends up all the way down here with another answer. It looks like a normal chat. It's just you're just chatting with a system, but in reality, you are going through multiple super intelligent iterations. It's response. There you go. So this is basically the idea here. The idea is that you're going through these iterations, and that's essential. Like each and every one of those is a form of exposure. And then each and every one of those is a decision that has to be made. And then lastly, these are the dependencies that you're making. You see how this iterative process have worked in that particular manner. Now, here's what's important for you to understand. You don't actually like this is software engineering in the AI era, right? I know as a software engineer for you, it's super kind of important for you to kind of think, okay, so what I need to go do is to write if statements and wait for the user to ask me about the weather so I can program the functions that will call the weather. That's not it. That's not it. You're done doing that, right? Engineering has evolved beyond that layer. That layer that you just talked about will be known maybe 5 years from now, probably less, as low level programming. Like today, what we're calling low level programming is assembly, writing maybe in C and all that. But what's actually going to happen is that AI is going to take over that layer. And what software engineering is going to be about, it's going to be about fine tuning these systems that can make intelligent decisions. It's a completely different kind of world that we're talking about here. So let's just come back to the architecture and I'll explain that to you. So if if an AI system is doing that for you, then what is exactly your purpose here? Like you're a software engineer, how do you program something like that? Let me tell you. So if we agree that any agentic and intelligent system in here is relying on data, decisions, and directions or actions, right? Then what's actually happening in here is that your engineering work is going to be more focused on what feeds these systems versus what these systems are going to respond with. For example, you will notice some people start talking about, Victor embeddings, right? Victor embeddings is all about kind of having the data embedded into your AI system, right? So your AI system knows about data that's coming from a particular place or a particular location, right? There's the Victor embeddings, there's live data, there's all kinds of different things. Decisions, that's the easy ones, right? Like that's, well, kind of easy. That's all about LLMs, right? It's about having fine tuning LLMs and managing LLMs, expanding the power of LLMs to make it make appropriate decisions, and make proper planning. This is all that investment into that area. And then the directions, that's what you hear about all the time, which is those MCP servers, basically. MCP servers. That's basically actions that are pre-configured and built with AI in mind. It treats AI as a first-class citizen where if AI wants something, it has already learned about an MCP server and what it can do, something like get weather, for example, and then it goes and gets the weather for that. Traditional programming is going to sit behind that MCP server. Just a little tiny bit of it sits here. That's your traditional programming. But it's not, but it's going to go away very soon because these systems are going to be so intelligent, it's going to develop its own APIs as soon as it just kind of learns about data sources. So don't kind of get your hopes up that, oh, I still need to build RESTful APIs. I still need to build, intelligent system in that particular manner. Um, the the areas where LLMs are going to come in handy, think about, fine tuning, right? What is a VLLM? What is an SLM? All of these investments that makes an LLM actually intelligent and make decision. That's where all that magic is happening. That's another branch. And then this area here, this is the data stuff. Think about, indexing of data, AI tuning of data. Think about exposure for prompts, all these kind of things. And there's a little bit of traditional programming sitting behind this area too, just a little bit, but it's not, that kind of programming that you expect to go and build me a dashboard and there's buttons in it and all that kind of stuff. All of that will be sitting behind the scenes because at some point in time, the decision and the direction will develop their own UI. So you're not actually building any UI anymore. You're basically building intelligent systems that will be able to kind of formulate and develop UI based on the person and the context and whatnot, right? That's the new software engineering, right? The new software engineering. And this is my theory about developing intelligent systems. Just so you understand, like at a larger scale, what basically happens is that this data and these decisions and the directions start to blur a little bit, meaning that what I just showed you in here is like the building component of an intelligent system. But what's actually going to happen is that you're going to have the exact same idea. Let me just make it really, really big in here. I'm going to call it data. I'm going to call this decisions, and I'm going to call this directions. And all of them are not exactly these resources that I talked about, but it's going to be intelligent systems talking to a smaller, more sophisticated, more specialized intelligent systems. So it's going to look something like this. Like these are just the building blocks. And what's actually going to happen is that you're going to have your orchestration at this point kind of working around that. Watch just the fractal nature of this. Like, let me just make sure it's the same size. There you go. Watch the fractal nature of these systems. So I'm gonna put that here. There you go. And then another one. There you go. Yeah, so these are systems that are talking to other intelligent systems. And while it still kind of lives with that purpose of data, decision, direction, it's not exactly pulling an exact source. It's just intelligent systems talking to intelligent systems. Watch this. And then this whole thing becomes a part of another system like this whole thing becomes a part of another intelligent systems that follows the exact same pattern. Like I get this question a lot from engineers, like, where am I headed? How is software engineering going to be? Do they still need a JavaScript and PHP developer? Yes and no. And I'll, kind of show you that in a second. But think about this guy. Now this is another big, massive system built out of another block of systems, and in and of itself it's serving the purpose of data, decision and direction, and it goes on and on and on like this. That's the nature of the tri nature thing. So let's come back to software engineer, right? So right now, AI is at this phase where it's still kind of collecting human experience, right? So you'll see a lot of this data labeling kind of thing. You see a lot of like, oh, keep the senior engineers and the principal engineers, at the point where it can kind of babysit AI, so it's not making the wrong decisions and whatnot. This is all like the experience kind of harvesting that's happening to train these large language models. But at some point in time, the systems will be so intelligent, so sophisticated, it will exceed what is measurable of human creativity today. It'll never be able to live up to the actual human intelligence and human creativity. Like intelligent systems as we know them today are just a mirage. It's like the illusion, like illusion of intelligence, when in reality it's just a really sophisticated autocomplete machines, but it kind of grows from there. It doesn't stop there, right? Like right now, it can imitate and do the work of an entry level, I don't know, entry level anything and anything, like an intern and anywhere marketing, for instance, whatever the case may be. But at some point in time, it will exceed that. It will exceed that expert level, and it already has scored, levels that are higher than people with PhDs and master degrees and whatnot. After this harvesting phase of human knowledge, right, as it's already working on harvesting that, it won't need that human knowledge anymore because it will be connected, to life in general, that it doesn't need your knowledge anymore. It doesn't need your expertise. It has already eaten up all that. And it's going to move into that phase where it's kind of trying to use that knowledge and develop its own knowledge and learn new knowledge to kind of start making smarter and faster decisions and take smarter and faster actions, right? So if you think, well, I work in an AI department as a software engineer, but when you're working in an AI department as a software engineer, if your job is around the fine tuning, the kind of the GPU layers, and oh, how do I do indexing, and how do we do like decentralized distributed systems, through the LLMs and whatnot, you're probably have a lot better chance, into evolving into this new phase of engineering than someone who's still doing the traditional, let's build a RESTful API, and let's create buttons and text boxes, and and have them do things, because AI is definitely headed directly towards that kind of thing. And you've already seen, go ahead and look at websites like Lovable, for instance, or anything, any website really, go and ask it to build you an HTML page or a Jekyll blog or whatever the case may be. It'll build you that in a second. You would need to hire a UI, UX, person to do that for you in the past, but now it's already doing that. So what I want you to do, like the outcome of this kind of quick session, and there will be a lot of, um, I'll teach you a lot more about this. I want you to keep that kind of map in your mind, because this map is going to be our way of evolving with AI. Instead of just saying, oh, it's taking our jobs, cry, 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 run, run, run. It's not going to be like that. It's going to be more like, okay, you're a software engineer. You have the, obviously you have the mental capacity, to understand systems and evolve systems. This is still software engineering, but it's a different kind of engineering. And if you keep that data decision direction map, in your head, I will show you how you can architect and develop some of the most sophisticated, intelligent systems. And we're going to dive deeper into each and every one of these and learn. This gives you like a simple and easy to understand map so you can navigate this space because you probably have tried, right? You probably have tried to learn AI. You're seeing all these videos, this explosion of content on the internet where everybody's talking about AI, but where is the map? Where should you start? How do you measure your performance? Where are you at? Are you good at it? Can you do more? Can you do less? What is an AI researcher? What is a data, researcher for AI and all that? We're going to talk about all this. I know this is not like a normal video where I kind of show you how to actually write code in C sharp or whatever, but this is more important than all of these videos combined because we're ready to move on to that new phase. And I want you to go with me on that journey and hopefully it'll be useful for you. If you have any questions, comments, concerns, please feel free to drop a comment in the comment section. And I appreciate you all. Thank you all for listening in all the way to the end of this video. And don't forget to like and subscribe.